Welcome to Maths for You channel. A past question on complex numbers. On an Argand diagram, sketch the locus of complex numbers w and z such that w minus 1 minus 2y, the modulus of w minus 1 minus 2y equal 1, an argument of z minus 1 equal 3/4 pi. Okay, let's start that. Let me write it down. W equal x plus iy. It's a sort of arbitrary format. X, y are variable, and w minus 1 minus 2i can be written as w minus 1 plus 2i. Just purposely, we need to find the a starting point. So the modulus of w minus in bracket 1 plus 2i equal 1. Normally, if the condition is the modulus format, the locus would be a circle. So the w with modulus condition be a circle. So w minus 1 plus 2i in bracket, modulus equal 1. And the circle, the center of the circle is 1, 2. Is w minus 1 plus 2i, therefore 1, 2 is the starting point or center point, and the radius is 1. Let's analyze z again. Z equal x plus iy, just arbitrary variable xy. The argument of z minus 1 equal 3/4 pi. Again, if the condition is given via an argument, then the locus should be a half line or line. So set locus with argument condition be a half line. And again, it's a pivot point or start point is 1, 0, because z minus 1 as can be written as a complex 1 plus 0i, so 1, 0. So we have found the center, we have found the starting point for line, then sketch the locus of w and z. Please accept my apologies for a poor sketch. Is how much I could have achieved or have achieved. Yeah, okay. It's circle, center 1, 2 as a circle, and again the radius is 1, therefore it will touch the imaginary axis there, so it will, the circle w circle is the locus of w, and the line, the modulus of z minus 1 equal 3/4 pi, therefore is a straight line, and starting point is 1, 0, which is a, and the center points of circle is c. So these are the two locus. One is a straight line, which is z locus, and the other one circle is y's locus. So locus of y, just to give you a bit more clarification or more info. The locus of w is x minus 1 squared plus y minus 2 squared. The center is 1 and 2 equal 1. And the locus of z, again, this is the gradient if you start with y minus x minus 1 y, because of the coordinates of a is 1, 0. So y minus 0 over x minus 1 equal tan inverse 3/4 pi. So y over x minus 1, tan 3/4 pi is minus 1. So tan inverse 3/4 pi is minus 1. And the equation for that straight line, this the locus of z is y equal minus x plus 1. So that's a sketch for part 1 answer. Let's do the second part. Let's see what second part is. Calculate the least value of modulus of modulus of w minus z points on the locus. Yeah, okay. So Right, let's do part 2. The least value, they have asked us to find least value for w minus z. So let's look at, analyze it further. W minus z would, would represent a vector between point on W and Z. That's just simply the W, a point on W and point on Z. Linking that two, it will give you the vector as W minus 1. But the modulus of that is the modulus of that particular vector, W minus vector. So W minus Z modulus is a distance between the point on W and point on Z. Simple as that. That's what that is. Right, for W minus, the modulus of W minus for minimum value, if you look at it, the coordinates of, the locus of Z is a straight line, and then we would like to find the nearest point on the circle. That must be a perpendicular line from center of circle to that line. So it's the W minus Z minimum must be on the perpendicular line on Z from the center of locus of W circle. Right. From the sketch, we can look at the sketch. I just draw a line from C to B, and again it's a perpendicular line. It doesn't look perpendicular, bear with me. So C, B and D is on the circle. So what we need to find, or what we have been asked to found, is BD, the distance of BD. So we have connect C to B, and we'll find it the distance BD. So distance BD. So again, if you work out, I'll go through the right from the sketch. As I said, W minus Z, the modulus is W minus Z minimum is BD. This is what the BD we need to find. Before that, we know that the BC, so the line from the center of circle to the locus of Z, is perpendicular to locus of Z. So BC perpendicular to that line, the locus of Z, we have found the equation y equal minus x plus 1. So the BC is perpendicular. So the gradient of that Z locus, which is y equal minus x plus 1, is minus 1. And because of their perpendicular, as you know, this perpendicular line, the gradients, multiplication of gradients is minus 1. M1 times M2 equal minus 1. So if its two lines are perpendicular, one of the lines gradient is M1, the other line's gradient is M2. If they multiply those two, is minus 1. But we know one of the line's gradients is minus 1. Therefore, the other gradient, so BC gradient, must be 1. Just look at it, say minus 1. M2 equal minus 1, so M2 equal 1. So the gradient of BC is 1. Then we can actually find the equation of BC because of the coordinates of C we know. So y minus 2 divided by x minus 1 equal 1 gradient. Then when you simplify it, y minus 2 equal x minus 1, y equal x plus 1. If you take 2 to the other side, to the right hand side, plus 2 minus 1 is plus 1. So this clearly says that this line will cut the imaginary axis at 0, 1. Yes, so the coordinates of B is 0, 1. Now we can find the distance between the BC first, because of BD. In order to find BD, we can actually do the BC minus CD will give us BD. Before that, find BC. is 2 points. 2 points, one C point is 1, 2 coordinates, and the B point is 0, 1 coordinates. So between the 2 points, the distance is bit of coordinate geometry. It gives you 1 minus 0 squared plus 2 minus 1 squared. That will be root 2. So BC is root 2. But we need to find is BD. So BD equal BC minus CD. If you could look at the sketch, BD equal CD minus, CB minus CD. Okay, BD equal BC minus CD. BC we just found root 2. CD is the radian of that, sorry, not radian, radius of that circle, which is 1. So root 2 minus 1. The BD is root 2 minus 1. Therefore, W minus Z, modulus of W minus Z, the minimum value is root 2 minus 1. Thank you. Please subscribe the channel and share with other students or people who may get some help from this contents. Thank you.